topic was platters. So I thought for a while about what kind of platter to make, and I went back and forth, and finally I decided that I couldn't decide, we'll do both. We'll talk about one, we'll turn the other. One of the platters is a vegetable platter. I turned a center section for the dip, made out of I made this out of 5/4 oak. I intended this project as to be done on a full-size lathe. I chucked it with an expanding jaw chuck. I used a cold chuck to reverse it. So because of the chucking, because of the size of the blank, the 4/4 oak was a little heavier than the other project. I assumed this would be an intermediate project, but it's a very fast project. I started this. This is a prototype I did just for the demonstration. I started it, I think, after my 8 o'clock coffee, and I was done before my 10 o'clock coffee. That included the finish. Because it's going to be in contact with food, you need some kind of a food-safe finish. I used a butcher block oil. I used walrus oil to finish it. So this will be one of the projects that I'm going to be talking through, because I assume I assumed it as an intermediate project. I assume that if you've got expanding jaws chucks, you know how to get the piece chucked up. So I'm not going to go through the details of how to use an expanding jaw chuck. Second piece is this. It will be a basket illusion piece. In the basket world, this would not be called a platter. It's probably be called a tray. The pieces that I do, I base them all on a real historic piece, a piece that actually exists, that was turned. So this particular piece was turned by a woman in one of the Pima tribes. I suspect it was an Okima Odom, which is a tribe south of Phoenix, north of Tucson in Arizona. I'll go more next. I'm getting ahead of myself, but I will go into more detail about the construction of the piece. The construction, though, I want to mention, because John brought in some pieces that he got, his wife actually got. They're made in Rwanda, and their construction is the same. The Southwest American Indian baskets, their pieces are not woven in the sense that you may think that there's radial pieces coming out, which are then woven around. They're coiled. There's a coiling process. And this piece, I'll pass both of these around, show the coiling process, how the actual construction is done. This piece, the foundation, the inside of the coil would have been cattail, and the outside is a thin strip of willow, which is wrapped round and around. So that's how the construction is done. So this is the what the piece is that we're going to be actually turning. Notice that the back of this is ugly. Your piece should be a lot better. It's ugly. Well, I'll explain why it's ugly when I talk about chucking it, but that was a chucking error. So take a look at the front, make sure your back looks better. The order of go today is I'm going to turn with Carbide tools. I've been turning exclusively with those for some reasons I'll explain in a minute, for the last 2 years. We're going to work on turning. This is a different piece I'm turning, but the goal today will have a piece that'll look in the white, something like this. It'll be a beaded piece that is actually, a platter. This is a shallow bowl, but we'll have a beaded piece made of poplar, and we'll get the guidelines in using a shop-made jig. And today, I will try to get this far. We'll try to get the guidelines in. We're going to ink the piece. The piece is done. The coloring is done with India ink. The outside piece is burned. I'm going to talk a little bit about the Native American baskets, how the baskets are constructed, what they're constructed of, who constructs them, the history, a little bit, because that informs how we make the piece. Because I think my pieces are more, I try to make them more of a reproduction or a model, as opposed to as opposed to simply an illusion. I want my pieces to be historically correct and look like the original piece. The piece that's going around was actually constructed by, I'm sure, a woman. They were almost all done by Native American women in around 1930. So we're looking at pieces that are about 100 years old. So I'll talk a little bit about the Native American basket making as it informs this turning. And that is similar to the piece that we're going to be doing today. I can pass that around. Quickly on carbide tools. I started turning about 25 years ago, and I turned for most of my turning hobby with traditional high-speed steel tools. I learned how to turn with high-speed steel tools. I learned how to sharpen them. And I've got a shop full of tools and jigs and whatever the jig of the moment was for deep bowl turning, or jigs to put a fingernail grind on a bowl gouge or whatever. A few years ago, I was diagnosed with rheumatoid arthritis. And one of the effects of that is to reduce the strength and dexterity in my hands. And I found out about 2 years ago that I could no longer comfortably turn with high-speed steel tools. I couldn't rotate the tool the way you need to rotate a skew, or I just can't get the rotation. I don't have the finger dexterity, and it's not, I just can't do it, and it's uncomfortable to do it. So I needed an option to keep my turning going. Didn't want to give up turning, so I decided I'd try carbide tools. As an experiment, I bought a carbide tool, thinking, paid $29. Thought that I would probably try it and eventually upgrade, because $29 didn't seem like I would paid enough for the tool. Turned out I've been turning with it ever since, and its partners. Bought 3 of them eventually, $29 a piece. My total investment in my 3 tools was less than $100. I could have got them cheaper if I had bought all 3 of them at once, but I didn't. I've got the tool. I was surprised how good the tool was for $29. It had a nice handle, looks like beech, stainless steel shaft, well machined. Came with a couple of cutters. It came with a wrench. Didn't know how to use it. Went online to the Union County Library and got an iBook on turning. It had a couple of pages on turning, very little, mostly metallurgy and out-of-date tool reviews. So I just got behind the lathe and started turning, and found out they're very, very easy to use. So what have I discovered in 2 years? Well, first of all, the cutters in the tool are independent things. You can buy the cutters and the tools independently. The cutters from different manufacturers interchange with the handles. So really you're buying a handle. So no sense in paying more than $29 for a perfectly good handle, because where the rubber meets the road is the cutters. From what I can tell, all the cutters are made out of the same alloy of tungsten carbide. They've improved it vastly over the last 15, 20 years. They all have an extremely good alloy that they're using that is very hard and fairly durable, so that they tend not to chip the way that they did in the past, although until you get in the moment, they still do. I suspect they're all come out of the same, if not the same factory, probably it's the same city in China. As turners, we are lucky in that we are getting the benefit of a really, really amazing technology in those cutters. And it happens because they're not making the cutters for turners. The cutters are being used in lots of other applications. For example, the cutter on this tool also fits perfectly in my joiner. They're exactly the same cutter. You can interchange them. So the cutters are used in industry. They're used for commercial applications. So we're getting the side benefit of some amazing metallurgy on these cutters. This is it's a Yofotol. Yofotol. Yufotol are the cutters that I bought. They're very easy to learn. The learning curve is very, very short. Within an hour, you can be pretty proficient in them. The book I read, the author who teaches both traditional and regular and carbide said that in his classes, the carbide people have finished their project before the high-speed steel people have finished sharpening their tools. You never sharpen them, use them and throw them away. I cut on the one edge, the front and the front of the two sides. So I get one rotation out of a cutter. So I get two edges out of each cutter. I rotate them once 180 degrees. They come in packages of 10 cutters for around $30. So they last me, a package will last me over a year. They stay sharp a long time. The manufacturers claim they're 120 times longer than a high-speed steel tool. What I find on segmented work, which I do a lot of, the glue is very, very hard compared to the wood. And if I'm doing a 16 segmented piece at 1,000 RPMs, that's 16,000 glue joints hitting the carbide every minute. And what I found after a couple of pieces is they started feeling dull, but when I looked at them, I could see just very, very small nicks in the carbide, and it was the glue that's nicking them. So what I do is every couple projects, I just put on new cutters. So I always have really sharp, perfect cutters, and a package of $30-some cutters will still last me a year. And you've always got perfect cutters. If you use them the way I use them, I'm going to give you a quick lesson. And my three rules: you never have a catch. So there's almost no drama using the tools. If there's any downside, and there's probably two. One of them is that the edge only sticks out of the tool 1.5 millimeters on this tool, so that they take a finer cut. So you get a continuous piece of wood coming out, just like you do with a regular tool, but it's thinner, it's finer. And if you're turning soft wood or green wood, you can't hog out wood as fast as you can with a conventional tool. So they turn a little slower. For me, that doesn't make any difference, but I find the finish on these is perfectly adequate, perfectly acceptable. They're used kind of like a scraper, but they don't scrape. They actually slice just like a gouge. So you get a finish like you get off of a gouge. And if maybe on a tough grain wood, I could do better with a skew if I could use it. But this is perfectly acceptable, and a couple of swipes with 400 grit sandpaper gets you to the same place. So speed is one downside. The other downside of anything I think of is mystique. If most people, I would say most, they say a lot of turners are wood turners. They turn to turn. They don't turn for the end object. And this just takes a lot of the mystique out. It's almost like it's cheating. It's too easy. You don't get the satisfaction of using a traditional tool in a traditional way and doing the sharpening and learning how to grind the thumb grind on your. It's just different, and it takes a lot of the mystique, a lot of the mystique, the turning that people come to enjoy out of it. And what I think of is it takes away from people who enjoy the process more than the end result. If you're, a lot of people I've seen, and I've done it. I was the same. I did that, and for a lot of years. You turn goblets with impossibly thin stems and maybe a loose ring if you really want to show off, because it's fun to do, because it shows your skill, because you can show it to other turners, because you can put it on display, not because your wife said she wants a useless goblet with a thin stem and a captured ring. It's the process, not the end result. And this takes away some of that. So that said, I'm going to give you a quick demonstration on how I use the tools. I use 3 rules, and I use them religiously. I don't break them. Rule number 1 is the tool is kept parallel to the tool rest. And because I'm have weakness in my wrists, I need to anchor it. I have to anchor it against my body. I have to anchor it against a tail rest. Somehow you got to keep this end from moving around. This end has to be anchored so the tool stays parallel. Number two, the cutting edge is even with the center of the headstock. That's a tool rest adjustment, okay? Number three, the tool is kept flat on the tool rest. So you need a square shaft or a shaft with a square bottom so that you are parallel, you're even, and you're flat, so that you're turning something like this. And that's all there is to it. You can go back and forth or up and in and out. You can go back and forth. You can pivot. But that's the entire motion and operation of the tool. And you'll see me use it. And everything I do will be either this way or this way or this way. If you get to a situation where you need to turn here, for me, I've got a problem. It looks like, but I don't, because I can turn left-handed and my lathe is out in the middle. I just walk around the lathe and turn left-handed from the other side of the lathe. If you can't do that, you can always turn this way. If you have a chuck that has a set screw that you can crank down so your chuck doesn't come flying off, and reverse the lathe. That's another way of getting to the same place. But that's all that I know about carbide tools, but it's gotten me turning, a lot of things over that have, come out pretty well over the last couple of years.
Why is it so important to anchor that way?
Why is it so important? Because there's only one way that I've found you can get a catch with this tool. The way that you can get a catch with the tool is if you overextend it too far and you lose leverage, the handle will come up. When the handle comes up, you're no longer parallel to the bed of the lathe, and your cutting edge is no longer even with the center of the tailstock. When that happens, the rotation of the work will rotate your tool so that the front of the or the farthest side away from you of the shaft will lift off of the tool rest. You're now no longer level, your point's not even with the center, and your tool's not flat. You've broke all three rules. And when that happens, the corner will dig in and it'll catch. Questions on what little I know about carbide? Yes. This was a Durtech. And one thing I do want to say is that they come in three. They come as a set of three. One of them has a square cutter, and they call it a rougher, I believe. The other one has a round cutter, and they call that a finisher, I believe. And the third one has a pointed cutter, a little diamond-shaped cutter, so you get a rotation out of it. And they call that a detailer. This one has a very small, maybe a millimeter radius on it. Okay, my square cutter is absolutely square. There's no radius on it. My diamond one has a slate radius on the end, so it doesn't come to an absolute sharp point. But what I will say is that I think the names are marketing, because they all give you the same finish. I mean, the rougher doesn't give you a rougher finish than the finisher. What I quickly discovered was that it depends on the shape of the wood. If you're cutting a concave surface and you try to get in there with a square cutter, the corners will dig in. Then if you're trying to cut something, a bead with a round one, you can't get it in there. So what drives the cutter is strictly what shape you're trying to cut. There's really no finish detail involved. So, one thing I do want to mention, from safety point of view, I have turned for 20 years with traditional tools, and you get wood accumulating shavings around the end of the tool. Okay. What I used to do with the regular tools is do one of those numbers and take the shavings off. You do that with this, and you slice all four fingers and your thumb. Okay, exactly 1.5 millimeters thick. And you won't know it until the work all of a sudden starts getting stained, and you're saying, what's happening? Why do I have red all over my work? So I keep a can of bottled air right on my lathe, which reminds me not to do that. I'd like to say I've only done it once, but that would not be true. I packed Band-Aids. I brought Band-Aids with me today. So if this is, it really needs a guard, quite honestly. This has a 1.5 millimeters of razor sharp blade that is proud of the shaft, and it will cut you. Okay, let's talk about chucking up some of this work. If you're doing the vegetable platter, I chucked it up on a expanding jaw chuck. The only thing I will mention, because it surprised me, I was afraid somebody was going to ask me how deep to make the rabbit. And I went to my manual and it said 5 millimeters. Okay, 5 millimeters is the answer. What it also said was that for a 10-inch platter on a Supernova expanding jaw chuck, your limit on the chuck is 680 RPMs. I didn't know that the tools had an RPM limit that was that low. So I just caution you to check your chucks as to what the maximum RPM is you can turn for a certain size within the rating of the tool. So what I did was I do it anyway, but I brought the headstock up to make sure that I was supported, or the tailstock to make sure that I was supported with the tailstock, because in fact, when I bead, I wanted to bead faster than that. So just be aware that you probably have a RPM maximum for a certain size blank on your expanding jaw chucks. So that was something that I was surprised when I went and looked at it. That's all I'm going to say about chucking that piece. Okay, this piece, that piece was turned out of a solid piece of 4/4 oak that was about a 11.5 inch piece of solid wood. This is turned out of poplar, and you should not try to turn it out of a solid piece of poplar, even if you have an 11.5 inch piece of poplar, for a couple of reasons. One reason is that it is very hard to bead across the grain when you have grain that's running across the wood. If you hit that grain that's going across the wood with a beading tool, it tears out. And the closer you get to the center, the more that it tends to tear out. So it's hard to bead. I designed this project to be done by a beginning turner. And as you see, I handed out my design. I didn't plan to do that. But I handed it out because I actually had the cutting pattern on there. I will mention that I design all of my projects separately from turning. If you haven't done that, I suggest you try it, because it really improves your turning. It makes you separate the design process from the turning process. And it prevents the problem where you get a piece that turns out beautifully and you don't know whether it was just a lucky accident or whether you actually designed it. Or you get a piece that turns out like crap and you say, did I just have a bad thought when I turned that thing, or did I just not turn what I thought? This way you got two different processes you work on separately. You can work on your design, you can work on your turning. And at least for me, you'll find out that it's a lot harder to turn to a design than you think. If you just put something on the lathe and turn it, you don't realize how bad you really are at trying to turn something precisely to a pattern. So it's a good exercise and might improve your turning. But anyway, I gave you my design. Can't use a solid piece of wood. It's hard to bead. It's hard to ink. We're going to ink this thing, and the ink takes differently depending on whether it's going with the correct direction in the grain or across the grain. And it's hard to burn. We're going to burn lacing along the edges, and the wood burner goes in differently when it's going with the grain and against the grain. So even if you get a solid piece and it doesn't split on you, it's hard to bead, it's hard to ink, it's hard to burn. So it's better to segment the piece. The way that I did this, instead of doing a regular segmented bowl, which this is, I I had to use my prop to fix my jig, so you're gonna have to bear with me here. This piece of wood that I started with was poplar. It was a 6-inch, a 1x6, which is nominally 3/4 of an inch, 19 millimeters. And the board ran this way. You do a series of miters with a miter saw, or a table saw, or by hand, and you'll end up with a series of triangles, 4 triangles that look like this. Glue 2 of them together to form a bigger triangle, which you'll see on your sheets, how it goes together, and you'll end up with 2 big triangles, okay? When you glue them together, the first 2 pieces, I didn't even bother to clamp them. I just put Titebond glue on, held them together. And you can hold them together for 30 seconds, and that's good enough. You don't need to clamp. When you get to 2 big triangles, you joint the long edges on both of them to make a perfectly straight edge. And if you don't have a joiner, you can put sandpaper down on a flat surface like a lathe bed or a piece of glass or a piece of marble or your countertop or whatever. Glue down a piece of sandpaper, run it back and forth. You need 2 flat edges, glue those together, and you'll end up with a square. And the square, you can see in how it goes together on the picture. Make a 10-inch circle around in that square with where the 4 pieces come together, okay? And that's your blank. And you'll end up with something that looks like this. I designed this so it could be done as a beginner's project or somebody who only had a pen lathe, a mini lathe. I did this to make sure that that actually worked okay. I chucked this up on I've got a jet lathe with a 10-inch swing. I chucked it up on that perfectly. This is so light and so well balanced. There was no vibration. The lathe handled it fine. I was right at the limit of the lathe, but this is doable on a 10-inch mini lathe. To chuck it, again, assuming a beginner project, I'm assuming all you have is the faceplate that came with your lathe. I recommend not using expanding jaw chucks. If you use expanding jaw chucks, you risk doing what I frequently do whenever I try it, so I avoid doing it. Is when you get the piece thin, the joint will open up from the expanding jaws if you crank down too hard on the jaws. This piece is ugly because I turned it with an expanding jaw chuck. And I had to patch up my joint with medium CA glue. So what we're going to do for the chuck is out of the waste wood from the poplar, cut a waste piece the same diameter as your faceplate. When I cut these, by the way, I use a scroll saw. I far prefer my scroll saw to my bandsaw. So whenever I can, I use a scroll saw. It cuts actually as fast, if not faster, much more accurately. I also did the 4/4 oak on the scroll saw. It just cuts for me better than the bandsaw. So this I cut out on the scroll saw. You get a very good cut with the scroll saw. So screw the faceplate into the waste blank. Make sure your screws are short enough so that when we part it off, you don't part off the screws. The waste blank is glued on. Yep. And then the faceplate is screwed on. And the screws are short enough to give me room for a parting tool, okay? If you use a carbide parting tool, it will in fact cut off your screws without any problem. But why waste good screws, right? I like to reuse them. So, any questions on getting this far with the project? Okay. The trick to doing a platter, or the trick to doing a segmented piece that you're going to bead, is to work from the outside to the inside. You want to keep as much material between where you're working and the center so that you don't get chatter. If I was to work this whole thing to final form and then tried to beat it, okay, when I tried to beat it, I'd get chatter with either the beating tool or the detailer. So I'm going to start on the outside edge. And the trick to this piece, to getting it, everything will fall together really quickly after we get this outside bead done. This outside bead is a 1/4 inch bead, 6 millimeters. The rest of these beads are 1/8 inch beads, 3 millimeters. And that's common in some Southwestern baskets. They typically did the outside with a material called bear claw, which is more durable than the willow. So it ends up being a little thicker very often than the other, very thicker than the rest of the beads. So we've got to get this outside 1/4 inch bead. The piece needs to have a little bit, we only have 3/4 of an inch to work with, but it's going to have a little bit of flare. So the bead has to be on the outside edge. It has to be in line with the flare. It's going to be more than 180 degrees because I want it to bring around it in the back and make the transition between the inking and the non-inking. So there's going to be a sharp transition on the back side of the bead. And on the front of the bead, the valley of the 1/4 inch bead has to meet the valley of the 1/8 of an inch bead, which is going to be next to it and set back a 1/16 of an inch. So the whole key is to try to get that first 1/4 inch bead in the right place. And then everything else just falls into place pretty well. So what I'm going to do, I'm going to bring up a tailstock just because I usually do when I'm turning. So the first thing I'm going to do is true up the piece, and I'm going to do that with the square cutter. Try not to poke my eyes out. The way that I'm going to true it up is to just go right straight in from the front. Okay, mission accomplished. Now trued up the blank. Next thing I'm going to do, got to get that tool rest in the right place. Because I have a slight sweep, I have to get that 1/4 inch bead in my head where I want it. And I want it to come in at a slight angle. So what I want to do is I want to establish a square that's going to surround the bead. So what I'm going to do is try to put I'm going to put a slight bevel on this that's going to be perpendicular to where I want, perpendicular to the sweep, if you want to think of it that way. So I'm just going to take this piece and I'm just going to come in like this. This is where I get into trouble. Cutting my hand. Okay, that establishes the sweep. Now what I'm going to do is I want to establish the front and the back of that bead. Now what I want to do is get my mind around 1/4 of an inch, or around 6 millimeters. So I'm going to give myself a line where I want that bead. This walls of this piece are not going to be parallel to each other because I'm going to bring this down to a foot. So I have so little to work with that I'm going to have to start sweeping to the foot fairly quickly. But I'm going to establish where that bead's going to be right now. Now what I'm going to do is just shape the bead with the round cutter, the finisher. Now what I have to do now is get that first bead in place. I got that cutter even. Okay. Let me talk a second because I need to cut a bead. Three options on the beads. One option on beads is to buy a traditional or a tool made specifically for beading. And that's what this tool is. It's a, I think the brand is, I think it's a D-Way. Advantages of the tool, I use it unhandled, but because of my strength, it's a little bit awkward for me, but it lets me get in behind when I'm doing the backs. I can get behind things with this because without a handle, the handle doesn't get in the way. And I can get inside of small bowls with it. So it's convenient that way. It does a very nice job on the beads. It's a little bit, you got to be a little bit careful with it because the tool is only 1/8 of an inch thick everywhere, and it thinks it's a parting tool. You can't feel where the bead stops, and if you're not paying attention, you just part your piece right in half. It works just like a parting tool because there's no thickness. It's not ground down to a thicker piece. The other second option is to just use a traditional beading tool. If you get a good one like a Sorby, it'll already be ground correctly so you can get beads next to each other. If you're like me and you buy a cheap one on the internet, or if you buy a cheap one on Amazon, you can buy a whole set for the price of one Sorby. I bought a set of 4 for $50. They're metric, but that's okay because 3 millimeters is 1/4 of an inch. Within woodworking tolerances, 3 is 1/8 of an inch, 6 is 1/4 of an inch. So they work out to English measurements, even though they're given in metric. They don't have a grind on the end, the ones I bought inexpensively, that lets you get close enough to do beads next to each other. So I had to grind them down to make it work. It's a cheap option if you don't mind doing a little grinding, and it works very well. It's a tool that I prefer to grind with. It has a little more heft and easier for me to hang on to. That's the second option. The third option is to just turn the beads with a detailer or a skew if you're using traditional tools. One thing I'll point out is that you got to remember you're doing a piece which was hand made in with woven materials, natural materials, and the original piece you're trying to make isn't perfect. So if you do hand beads and they're not quite perfect, that actually adds to the realism. It doesn't subtract to the realism. If you make this out of, say, maple, something which really holds the beads really well, and you make perfect beads, when you get all done, you're not going to have something that looks like a basket. You're going to have something that looks like a beaded maple bowl. Okay, so a little bit of variation is consistent with what we're trying to accomplish in the realism of the piece. Okay, so that's the three options. What I'm going to do now is give myself a little bit of room down here. This is going to come in. Somebody's got the plans there. How deep is this piece? How deep is this? 5 millimeters? 5 millimeters. Okay. So I'm going to give myself right here 3 or 4 millimeters to work with. That's the next thing we'll do. I'll use the round tool for that. I can't get right up close to the, I can't get up close enough to that that bead. So I'm just going to, whoops, no, I'm not with that tool, I'm not. That's why you have more than one tool. I was going to use the square cutter. I didn't give them enough room, so I'll use the detailer. The detailer is tapered, and I want the widest part of the tool on the tool rest, and I'm too close for the detailer. So I've got to back off a little bit so I'm onto the thick part of the tool. So I need to be on this tapered. I want to be here, not here. I was too close for the detailer. Now I'm hitting the tailstock. This tailstock is different than my lathe at home. I'm just gonna have to get right out of the way. I'm running into problems getting anchored. What I'm gonna do while I'm here is I'm just gonna touch up the speed. Now what I'll do is I'll get that first bead in place. I want to get 4 or 5 beads while I still have a lot of thickness on the back. It's easier with a beading tool if instead of doing the beads one at a time, you lay them out next to each other and then go back and finish them. It's easier to line them up. So that's what I'm going to do right now. Okay, that's gonna work. I've got some roughness right in there. I want to fix that before I go any farther. I'm gonna use the detailer just to clean that up. Okay, so we've got that much done. Now what I'm going to do, I've got just enough time before we break to start the back. On the back, I want to do a foot. How far in is the start of the foot? Will somebody tell me off of the, I think it's about 40 millimeters. So we'll come in about 40 millimeters. That's where we're going to start our foot. So what I need to do now is remove some material from the back. I'm going to use a detailer now. I'm going to clean up the back of this bead. What I'm going to do, just so I don't forget, when I get this far, I don't plan on coming back. So I need to slow this down a bit. And I'm going to just clean up this bead with the final sanding. A little bit of roughness is a good thing, but too much roughness wears out the tips of the pens. The India ink is put on with a brush pen, and I'm going to clean these valleys up just enough so that it doesn't cause premature wear next week when we do the inking. Okay, what I'm going to do is try to give myself some, while I still have some room here, I'm going to bring this down to the level of these beads and get about half of these beads in. Then we're going to move to the back and get down to the foot. So I'll be in about this far. Completed is where I'm going to try to get now, and kind of quickly.
So you're leaving some meat in the back while you do the front, then you go back to the back.
I'm gonna do this, leaving meat in the back, and then I'm gonna go into the back and finish that up and gradually work my way in. Especially for me, I cannot turn, I have no way of damping out chatter. I can't take my hand off to do it. I need both hands on the tool. If you can turn with one hand, you might be able to damp some of that chatter out. I can't do that. I've got to try to keep the chatter out by keeping as much beef as I can toward the center of the piece. If you're doing a bigger platter, it's even more important. Okay, this one is going to be fairly thin, so it's also important on this one to try to keep as much beef as I can. I don't need a perfect surface there. Just did it because I'm going to beat it. Fortunately, I didn't cut myself. I'm going to clean up those valleys. I got one valley that's, I didn't get the tool exactly the right spot. And I got one valley which has got a little debris in it. I got to fix.
Are you using the edge of the sandpaper?
I'm folding the sandpaper over and putting the crease down in the valley just to get the debris out of there so it doesn't ruin my pens next month. Those beads aren't perfect, but that's part of the realism of the basket, so I'm not really too concerned about that. I'm in about that far, so now that gives me, actually, I think I better go a little bit farther before I go back and do that. Yeah, we're good. What we're gonna do now is work my way back down to where the foot's gonna be. I gotta be careful I don't get too thin. I'm gonna turn this left-handed. Gotta bring the rest of this down now. Too close. If I was doing the vegetable platter, I'd turn that center part now for the dip, but I'm not, so I won't. I'm just turning just by pulling it toward me, pulling the tool toward me, keeping it flat on the tool rest. I can feel any imperfections if I've got them. Want to eyeball that one against a straight edge. Magnets on here for the next part of the project, which are going to cause me trouble. I'm still fat in the middle. Okay, one more quick thing here before we put the design on. I'm just going to finish up this foot in the back. Joe suggested collars on these tool rests to keep them at the right height, because as long as your tool thickness is the same, it never changes. That's a good idea. Tail rest up to get rid of that chatter. I mean, the tail stop. Got quite a bit of wood there, but I think I'll leave it. Make that foot a little bit more definitive there. And I gave myself an edge I don't want. Now I got myself into trouble because I'm thin here, but I made a edge, a little bit of a unevenness. Sometimes the safest bet is to sand your way out of trouble. Okay, mission accomplished. That took care of that. Okay, the next thing I have to do is put guidelines on. I'm going to use a shop-made jig that I'm going to show you how to make next session. I've got an adapter on this lathe to knock it down to from inch and a quarter to an inch. I use it on my lathe at home, even though my lathe at home is also an inch and a quarter, because it gives me an extra 2 inches to work behind the piece. And I like the extra work room in back. And then on my chuck, which is also an inch and a quarter, I have an adapter in that. So I've got adapters going everywhere, every which way. This I'm going to take off. I'll explain how to make this next session. This is made out of a pipe cake riser from Hobby Lobby. And this is what the pattern is actually going to be on the front of the piece. That I'm going to show you how to make that using an app that makes polar graph paper. It's going to go on like that. And that's going to go on like this. It looks like it's backwards, but it's not. This goes back on. Okay, what we're going to try to do is use this to put on the design for the piece. And I've got the design on the back of this. I'm going to put this on the lathe with magnets. Let's see, this rule is going to be my pointer. It's going to point to the spot that I need to, I hope. Then I use these little clips to hold the thing in place so it doesn't move on me. And we'll draw in the first of the lines. Move it up to the next one. And the next one. Well, there's no reason that I can't go all the way to the lip, except the design doesn't quite go all the way out to the lip. So when you see the design, this outer edge is not going to be part of the design. So I only need to get it out far enough to do the design. These are only guidelines so that if I get one that's not quite out far enough, I can always just extend it out. If I was doing one that had the design on the back, I would also be doing the back though, at the same time. This design is done with polar graph paper that you custom make using an app. So you can make the custom graph paper any number of radials and any number of rings. And then you can also use it to color in the design. So it's really a really neat app. I use it on an iPad. And then when I get done with the design, I just glue it onto this jig and then just use this jig to transfer the pattern. I'll pass that around if you want to see what that looks like. Okay, that's kind of the meat of the show. But what I'm going to do next is part it off and finish up the back. I don't have the luxury or the dexterity to catch a piece when it comes off. So I'm just going to finish it up with a saw. Okay, that's done. Now, The way that I'm going to do the back, what I would normally do is smooth this, even this out with the square tool, and then apply tape. I'm going to skip a step for the interest of speed and just put on a different chuck that's already taped. I'm going to use tape to reverse mount, to reverse this piece. Normally I'd use cold jaws, but because I'm doing this as if it's a beginning turner, I want to show another way of chucking this. I'm going to do it. I'm just going to tape it using a double-sided tape. This is a double-sided gel tape. Works very well, in my experience, to reverse the pieces. I also use it sometimes just to do a plug, for example, on the segmented piece. So we have the luxury here of having guidelines. We have rings that we've already put in. So all I've got to do is figure out which ring is the right one. That one, that one, that one, that one, that one, that one. I think it's right there. That will work. So what I'm going to do, take the backing off of this tape. Put this on here. That's good. I've got to make sure this bottom is in farther than the feet, so it sits flat. Okay, that will work. Now what I'm going to do, I think before I sand it, what I usually do, give myself a line that I'll use as a guideline when I sign it. And that adds a little decoration also. Okay. That is it until next month.